Imagine you own a popular coffee shop with only one door. Suddenly, 1,000 customers try to enter at once. What happens? Chaos. Gridlock. Crash. Your website is the same. One server cannot handle the world. You need a traffic cop. You need an elastic load balancer. AWS Elastic Load Balancer, or ELB, acts as the single point of contact for all incoming web traffic. It sits in front of your application servers and automatically distributes requests across multiple targets, like EC2 instances, containers, or IP addresses. It ensures that no single server is overwhelmed while others sit idle. The primary superpower of an ELB is high availability. If one of your servers crashes or becomes unhealthy, the load balancer detects it instantly. It stops sending traffic to the broken server and reroutes it to the healthy ones. Your users never notice a thing. The service stays online always. AWS offers three main types of load balancers, each for a specific layer of the OSI model. First, the Application Load Balancer, or ALB, for HTTP traffic. Second, the Network Load Balancer, or NLB, for ultra-high performance TCP traffic. And third, the Gateway Load Balancer, or GWLB, for third-party security appliances. Let's break them down. The ALB operates at Layer 7, the application layer. It understands HTTP and HTTPS. It can look inside your packet headers, cookies, and URLs. This allows it to make intelligent routing decisions based on the content of the request. It is the standard choice for modern microservices and web applications. Because the ALB sees the content, it supports advanced features like path-based routing. You can send requests ending in /API to one server group and /images to another. It also supports host-based routing, allowing you to host multiple domains, like example.com and blog.example.com, behind a single load balancer. For pure speed, you choose the Network Load Balancer. Operating at Layer 4, the transport layer, it handles TCP and UDP traffic. It doesn't care about cookies or URLs. It just looks at ports and IP addresses. It is designed to handle millions of requests per second with ultra-low latency. A unique feature of the NLB is that it provides a static IP address per availability zone. This is critical for corporate firewalls that need to whitelist specific IPs. If you are building a gaming server or a financial trading platform where every millisecond counts, the NLB is your weapon of choice. The newest member is the Gateway Load Balancer. It operates at Layer 3, the network layer. It is built to deploy and manage third-party virtual appliances, like firewalls, intrusion detection systems, and deep packet inspection tools. It allows you to insert security appliances into your network traffic transparently. Behind every load balancer lies a target group. This is a logical grouping of your backend resources. A single load balancer can route to multiple target groups. For example, an ALB can route port 80 traffic to a target group of EC2 instances and port 80 to a target group of Fargate containers. How does the ELB know a server is down? Through health checks. The ELB periodically pings a specific path on your application, like /health. If the server returns a 200 OK code, it is healthy. If it times out or returns an error, the ELB marks it unhealthy and stops sending traffic until it recovers. Stateless apps are best but sometimes you need to remember the user. Sticky sessions, or session affinity, bind a user's session to a specific server. If I log in to server A, the ALB ensures my next request also goes to server A, so I don't lose my shopping cart. This is configured at the target group level using cookies. By default, each load balancer node distributes traffic only to servers in its own availability zone. With cross-zone load balancing enabled, the ELB distributes traffic evenly across all registered targets in all enabled availability zones. This prevents an imbalance where one zone is overloaded while another is empty. ELB is also your first line of defense. It integrates with AWS WAF, the Web Application Firewall, to block SQL injection and accesses attacks. It also handles SSL termination, decrypting HTTPS traffic at the load balancer so your backend servers don't have to waste CPU on encryption. To recap, use ALB for flexible, content-based routing for web apps. Use NLB for extreme performance and static IPs. Use GWLB for scaling security appliances. Mastering these three tools is essential for any AWS architect. That is AWS Elastic Load Balancing explained. Stay balanced and follow @CloudDecoded.